Hi guys, just a few minutes on these Bourke engine parts to get an idea what they look at. This is the rod yoke assembly. This is the track that goes around the cam roller bearing. You see the faces in there. I'm trying to follow this on the camera too, but I think it's okay. Come on. And right here we put shoulders to keep everything nice and straight for precision assembly. These plates were made out of 01 ground, 01 oil hard. I don't know if it'd be better to cut them individually, but was thinking about cutting them, well, we did, out of one plate. That way two cuts would be absolutely parallel. And these were precision ground afterward, but the 01 is pretty good for heat treat. And this was done with 2 dowels. Here's a connecting rod. And this is where the action is, right here. The roller faces. Both of these go up against the big roller bearing. You can see the outskirts here of the arm alloy chrome. And they should be shiny as a mirror. So these surfaces also were arm alloy chrome. These could be cut from a piece of plate and hogged down to this, or we could get flame cut blanks where this would be square, of course, with flame cut blank, and then it would be much easier to just hog that off and bring it down. And these are going to have to be oversized for grinding, because you can see, I don't know if you guys can get that kind of finish. If we get a really good finish, then we can just send it right to chrome, but I don't know. These are the 4140. And this track right here, that's keep them going in this direction. So this area is critical as far as the thickness dimensions. And seeing is going to the grind shop for the faces and for the rods. They'll do all the rest of the faces too. It's going to have to go to grind shop, I think, unless we can get these right. Or not right, but where there's, you know, usable. And then here's the crankshaft. And this again, 4140. And my question was whether we can do the journal like they do on the internet, where the axis follows it around. To be ground between centers, because we want it absolutely straight, and also to be ground on a crankshaft grinder for the journal, because that absolutely should be ground. This one was never chromed. And on these cranks in particular, you wouldn't think so on an automotive crank, but they got the detachable counterweight, and this is just a piece of cold rolled. There's really no reason we have to heat treat this. But the flats on these right here and right here register on the flats in the crank, which is unusual. Usually they come right with the crankshaft itself, but the reason being is that the bearing, the main roller bearing, has to be able to be attached to the center, and this slides over, and this slides over. So the big deal here is these things are attached by sliding over the flats. This may not fit because these are mongrel parts. Excuse me. And that union right there is good, as it's called out as thousandths of an inch clearance, but I find the closer you can get it, the better. So the crank will have to be ground also. So the same thing, flame cut, and put some centers in, hog it round, do the journal, get it down to pre-grind, and that's it. And I'm afraid they have to go to grind because they have to be heat treated, and usually after heat treatment, there might be, well, not usually, but occasionally there's movement in the parts. And this is what the whole thing looks bolted together. Although on the original engines, they didn't chrome it, but they did get a highly polished surface right here. And this is one of the original units. So it's a case of kind of experimenting to find out which is the best way to do it, the cheapest way to do it, obviously, and something that's going to give us the performance that we're looking for from the parts. This is just like a hydraulic cylinder when you're done with it, so that we get nice sealing and we got control of the oil. So that's it for the steel parts. There's really not a lot, but the thing is, when they bolt into the assembly, they want to be, this is the toughest part right here, is 0, 0, 0 between centers, because you can't have this flying back and forth and have run out or bent or anything. You're going to have vibration, wear, and all of that. So the construction of the yoke assembly depends entirely on the truth of the parts that it's built from, obviously. So there was a few things that Russ did, and actually I don't know if you can see it in there, but there's a little bit of a center left on it. And to make the rod, I put a false center on here and just pierced this surface with the center. So after the machine work is done, this can be taken off and they can be ground between centers. So anyway, that's the steel parts. This one is, actually these were made at the Torrington Company, Ingersoll Rand, many years ago. And it's just a simple bearing, heat treated and precision ground. You want them nice and smooth, as simple as that. The half shells are alloy called Armalloy, not Armalloy, but Amco 18. And the latest Amco 18, I think they've updated this alloy quite a bit, and there's some special machining, what do you call it, program, that, not program, but procedure you got to use for it because of it. But anyway, we'd be looking to have those bearings. These easy, CNC would probably knock these out like mad with the right size stock, then send them off to heat treat and grind. These things out of cold rolled. I don't think I ever had them heat treated. And then the rods. So that's the steel parts. So anyway, I hope that covers it. I know we'll be speaking a lot more in the future about it, hopefully. And then we'll just cross every bridge as it comes along. Most important, 0, 0, 0. Scares a lot of people, but it is doable. Thanks a lot, guys. GoPro, stop capture.